And now we are still at the level that we have ideal sources. And this is the level at which we expect to that you do your homework, that you are going to make your two-stage antenna, active antenna with a differential pair input, and that you are making the ideal biasing. So the concept with ideal sources. And not more than that. We next time after the holiday we will discuss definitely implementation of biasing elements, but it is not part of your homework. But we want to talk about it before because it has a serious impact, of course, on what we are going to do. So we are using for this nonlinear resistive elements. That's what we need. We need something that behaves as a current source, but it is not. It's a passive element. So, or something that behaves as a voltage source, but it is not. It is a passive element. So how does it look? How do the characteristics of such a device look? Let's start here with a current source. A current source in this VI plane would be a perfect one in the horizontal line at the reference IRF. But any passive device must have its VI characteristic through the origin. Otherwise, it cannot be passive. So it means zero voltage out when there is zero current in. So it means there is a region in which we go from a kind of resistive character to a current source character. And for any practical device, this region ends somewhere. If you put too much voltage across the device, you'll bring it into breakdown and it doesn't give you the reference anymore. Of course, this is an abstraction, but basically, this is what you would like to have. But you see, such a current source only works between the saturation voltage and the breakdown voltage. And this has to be accounted for during the design of the biasing. We need that headroom. We cannot use this current source for all voltages across it, as we can if we put ideal current sources in there. But no, not if we do a practical one. And everyone knows probably the saturation of a bipolar transistor and the linear region of a FET in which we have this behavior, this kind of resistive behavior for low voltages and low currents. So current sources, current source behavior, if you want it from a passive device, requires a voltage drop as shown here. And we can only use those devices if the voltage is between saturation and breakdown. And we need that headroom for our devices. It's one of the specs for our current source to be constructed somehow later on. The same holds, of course, for voltage sources. You just take the same picture and you change the axis. That's all you do. And then we have a voltage reference, and the voltage reference can only be made if you let a current flow through the reference. That's what you probably already know from Zener diodes. If you put no current through a Zener diode, the voltage is zero. It's not a battery. So somehow it has to reach the Zener voltage and then become constant. And that is called the cut-off current. Below that current, it works as a resistor and not as a voltage source. And of course, if you put too much current through it, you will get a kind of saturation effect. I call it saturation. Maybe you can also call it breakdown. It is, I think there's different names used for that. So the voltage source requires a current flow, and the voltage source can only be used if the current is between cutoff and saturation as shown in this picture. Now let's go back to our biased, two stages biased. So here we had this folded cascode, and now I replace simply all these current sources with this kind of nonlinear resistive elements. But you also see that the voltage source at the gate of the cascode, as the P device, uh, is also a nonlinear resistive element, and it needs current. And I have added that current through the voltage source just to bias the voltage source. So basically, you have to realize that your biasing elements should be biased. That's basically what it states. And that is also what makes the biasing, of course, a little bit complex. If you don't understand that this is basically a step by step approach in which you do different things and you mix everything together, it becomes so complex that you don't even know where you are. So that's why we want to present it in this way, step by step.